Okay, good morning or afternoon. It's my pleasure to spend a little bit of time with you talking about the new features in the 2026.1 version of SA, which finally is now available and can be downloaded from our website. This is something that we've been working to get out the door for quite some time, and we really feel like is a real accomplishment because it covers a lot of great areas. So let me get into it, talk about some of the things that we've done in this version. Okay, so first of all, we've had some pretty significant focus areas. One of them was robotics. And as you know, SA does do a fair bit of robotic inspection and has a lot of tools for precise measurement. But what we really didn't have was a way to combine scripted or SDK type applications with actual robotic control in a real-time environment. What we've done in this version is add OPC UA, which allows event-driven and more seamless manufacturing processes. The other thing we did was expand our ability to use devices like the ATS800, the API LADAR, Nikon laser radar to allow you to do this type of precision scanning and integrate that with a robot. And the advantages there is that you can combine both this dynamic robotic control, custom calibrations, and these advanced instruments for some really advanced manufacturing processes. Combining that, we also were expanding our abilities just across SA in general. So what we did was work on measurement support using CAD and perimeters. So we have more advanced tools for extracting features from CAD. And we spent a lot of time working on cloud extractions, cloud processing, and accelerating and refining that process. It's been a revolution that we've been working through for the last year or two, and it's really coming together. So start off, let's take a quick look at this OPC idea. So OPC is a unified architecture, provides a single, secure, and reliable cross-platform work frame for basically doing what I'm saying. Is basically how do you drive a robot or a PLC? How do you combine systems? How do you work with them in a real-time environment? And one of the other things that we did recently was put out a marketing video on SARCA, which is a standalone calibration unit. So what we can do is really work with you to calibrate the robot, calibrate not just across all movements of the robot, but within specific calibration zones, and then apply those zones for very precise measurement calibration under certain conditions. And this OPC really allows you to pull that together and work with more real-time scripted applications. So what we did in this version specifically was add 25 new MP commands and the idea of a subscription service, which is really what's new. And what that did was allow you to do time intervals, callbacks, PLC heartbeats, notification services. It's the real-time aspect, and I'm not saying real-time as in, microsecond. What I'm saying is you really do have the ability to talk back and forth and reliably communicate with the devices as needed. So we really have expanded that out. And I threw this in just for fun. This is a slide we've had around for a little while, but there's a reminder that we actually do have the ability to do real-time measurements using robotics. And so this was a fun demo we put together where we moved the 800 on a little robot and did the scan completely. And that's just kind of an example of the kind of thing that you could do with SA. One more fun one. This one's actually from, I think it was from some sort of sales presentation, but the idea is that you can get much more advanced if you have a bit more creativity in looking at what you like to do with robotics and robotic inspection. And I wanted to just plant the seed that SA is really set up to allow you to do this sort of advanced manufacturing processes. Okay, move on a little bit. Also sort of on the automation side of things, what we did was work with Google Sheets. And as some of you may know, Google Sheets offers a very nice alternative to Microsoft Excel sheets. The major difference is that they are online only, and so it's really a cloud-based solution. It allows you to directly access individual cells, perform calibration, perform operations within those cells, and we now have tight integration with that using MP. And where you really get the benefit for that is when you're working remotely. So say you have someone in Europe working on the same Excel file, or Google Sheet, as I should say, on the cloud, and you can have someone here in the United States writing to the same one at the same time. So there's some real direct interaction, direct feedback that's possible with the Google Sheets operations, and all of that has now been worked out and added into SA as well. Okay, so moving on to the instrument side of things. What we really wanted to do was streamline these devices. What I've done is kind of tried to define them as precision scanners. In many ways, that's a good definition. It allows you to scan a surface with quite high precision, looking at edges and features and trying to understand where they are in space. What we've been doing is spending a lot of time working specifically with the ATS800, and there's a good reason for that, because it's not just a precision scanner, but it's also 3-in-1. It allows you to do room scans, region scans, but also work with an SMR just like a regular laser tracker. And so by supporting that device alone, we really are looking at the whole suite of the primary manufacturing process and understanding what the needs are. So we're pretty proud of being able to pull that all together, and the things that we've been doing has been directly trying to work with that instrument to make it as effective as possible in doing templated feature inspection. So a couple of specifics on what we did in this version. We did update our CAD package, so we do have updated support for a couple of different formats. We've also added better handling of CAD faces within features. So if you wanted to measure specific faces, we have the ability now to recall the list of faces from a relationship, access them directly, and edit them rather than having to recreate them. So that kind of simplifies face selection. And face selection is kind of an important thing when you're scanning particular regions of a CAD model, and so that was an area of interest for us. And when you come to actually scanning those regions, you need to be able to both build a definition of where to scan and guide the instrument. So what we've done here is provide a really nice way of using perimeters, either directly from the CAD model, where we've built a tool for extracting edges and unique contours by just simply hovering over them, and also by taking planes and intersections and working on trying to figure out how to use those to refine the intersection between that plane and the model, so that you know exactly what you're measuring and you can limit that measurement to what the instrument can see. So I think we also have a video on that, so you may want to take a quick look at ideas on how we could do that. There are a couple of other additions specifically for the 800. What we did was add an angle filter to the instrument to help reduce noise or outliers within the dataset, so that's kind of a nice addition. We've increased the ability to do path planning, so if you're scanning, for example, a cylinder, you are able to scan either the exterior of that cylinder or the interior portion that you can see, like the end cap of that cylinder. So if you're scanning down into a hole, or if you're scanning a pin, you can simply define the orientation of the cylinder and the instrument will know how to handle that. The other thing is we've solved a couple of workflow issues related to measure batch of features. So in the prior release, you simply had to configure each feature in the way that you wanted to measure it in advance, and then it was ready to go. Well, in the current version, we now have defaults. So all you have to do is add the feature and hit the measure batch of features function, and SA will immediately tell the tracker what to do, and it'll go ahead and measure. So those are kind of some nice additions for the precision scanner measurements. Okay, moving on, let's look at cloud formats and cloud processing. Cloud measurement has been something that SA has really not tried to delve deep into until the last couple of years. We were primarily looking at larger point-based measurements, but as the industry starts to shift more and more towards cloud-based measurement, and particularly as we continue to try and support these precision scanners, we've been working more and more to try and find ways to really support cloud-based feature extraction and templated extraction, and trying to help visualize cloud data in a way that we've never been able to do before. So we've been working on this new enhanced cloud format, so I'm looking at that, and one of the nice things about this new format is the color, the display, the RGB color, that sort of thing. We've also been expanding our ability to use MPs and SDK applications specifically with cloud data. That's something that wasn't available in the enhanced format in the prior version. So there's a real reason to move forward if you're looking to do automated processes with this new cloud format. We've also improved reporting features, so we've really modernized the display and the colorization controls we have. And finally, we really have just across the board improved things with feature extraction. So let's take a couple look at some specifics here. One of the things that was missing was a surface point normal. So if you scan a feature, you really don't necessarily know the direction of the surface unless you look at the points around a single point. And based upon the data that's there, you're able to calculate a local normal. This is something that SA didn't do before, and now we have it. We are able to accurately calculate a surface normal, and you can visualize that directly within the point data. And we can also save the probing directions of the scanner if you're using an AS1 or something like that. Sometimes it's helpful to know how the measurements were taken. I also mentioned that colorization and reporting was an important part of this. This is again something that SA hadn't done well in the past, and we do quite well now. One of the things we have is extracting meshes from CAD so that you can work directly with mesh more effectively. And we've really worked to ensure that our mesh extractions from CAD are as accurately depicting the CAD as possible. And there's some real clear numbers now based upon how that's done. We also have a colorized mesh. So let me go through a video briefly and see if I can't show you some details about that. Okay, what I would like to do now is share with you some of the cloud-based visualization and analysis tools we've added in this version of SA. So in order to do that, what I'm going to do is just import a scan of a car door, and I can do that by just dragging and dropping an RSC file in, and I can import it directly to a particular instrument and then play it back as if I'm live measuring. And as you can see, we now have the color intensity display, which kind of improves the graphical rendering of the cloud data. And it looks almost like a mesh, and it shows the reflections from the metal. What's kind of fun about it is that it's such a big step above what we had. And just as a reference point, what I can do is save it as a scan stripe cloud, which was our prior format. And you see it immediately looks kind of thinned out. It's a little harder to see. And the other thing you can do is turn off the intensity data, and suddenly you'll see the way that we were displaying cloud data before our G Cloud or enhanced clouds, and how much of an advantage it is to turn that off and see cloud data displayed like this, which is just a lot of fun. The other thing that we've got, let me hide that CAD model for a second, is if you zoom in and you look at the cloud data, you have the ability to actually zoom in and segment just the part that you're interested in. So I can right click and split the cloud by selecting a zone, and I'll just do that. And then in this zone, there are features that have some curvature to them. And if you want to look at the curvature, what we have, and the reason that our lighting has improved so much, is we now have the option to show the point normals. And this option allows you to look at the individual probing directions or surface normals saved with every point. That's a significant advantage to being able to do feature extraction and surface analysis, is having a local normal per point, which is something that we were not able to compute before. But now it's just naturally part of the cloud data. And again, you can just simply right click and unsplit the cloud to see the big picture. And you can see the normals are available for the entire cloud. Again, you can zoom in on a particular zone to get at the detail per point, but it's just kind of a nice feature for the whole cloud analysis process, and you can turn it on and off in the properties. So that's the first thing for cloud display. The other thing we've been trying to work on is take this cloud, and rather than just directly comparing it to a CAD model, actually allow us to work with a mesh. So under the clouds and surfaces, there's now an option to build a mesh from CAD. This is a great option so that if you forget to build a mesh from the imported CAD, you can directly build it from an existing CAD model. And we've refined it so that you can build a much more refined, more precise mesh. If you turn that on, you'll see it doesn't even look like it's any different. But if you go to wireframe, you'll see that this is a mesh and it's got very fine detail, and the detail is based upon the density of the feature. So we're keeping very high detail, and we have specifications for the detail of the mesh that we build from a CAD model. So those are the things that we've done to just simply be able to improve cloud display. And if you do align, you can then do extraction relative to this mesh. So I'm just going to right click and say align to mesh and select the mesh for alignment and compute the alignment. Okay, now that we're aligned, what we can do is use that mesh for colorization. So one of the really cool things we can do is go under the reporting tab, and we have additional options under this query cloud to objects. We can do direct cloud-to-cloud comparisons now, which wasn't available for a little while. We have the ability to now build a colorized mesh as well, and a colorized cloud, which I'll show you in a second. But let's do this first one, build a mesh as a colorized map of the cloud to the mesh. So I can select the point cloud and select the mesh. And then if I hide the original and the cloud, which has intensity, you can see we have a colorized mesh. And if you want to, you can add callouts. So we have callouts for a mesh as well. So I can select that zone and add a callout. You can add another one over here just as a reference. And let's do, say, one over here just for fun. So these callouts are now linked to the mesh, and you can do a full rendered visualization, which looks even better. And then you can also just right click on the mesh and access the colorization settings. So if the settings aren't quite right, if you don't like this, you can switch the mode, say go, no go as an example, or you could even do something sort of intermediate, which is like tolerance continuous, which is kind of a nice display. So this display then is immediately available for laying out your callouts and adding it directly to a report. What I'm going to do now, though, is hide this mesh and go ahead and use the cloud. So we have another option here, which is to build a colorized cloud. So I can select the point cloud and the mesh and do a colorized analysis. And what we have now, and this is actually kind of neat, is the cloud data itself. And I'll hide that call out. So we can look at this cloud itself and see that there was a piece of the mesh that was actually missing. And so we actually don't have any data here along this edge. And you can see the same colorization and the same lighting for the cloud. So in many ways, this is a really accurate and effective way to look at the colorized data using the cloud itself. And again, if you want to add color callouts, you can just simply right click and select a zone and add a callout to that zone. So I have a callout here. And if you want to adjust the colorization, again, it's simply right click, access the colorization, and adjust the colors to whatever color display fits your needs. So we have all of the same options for basic colorized cloud, which is colorizing the measured data, or a real true color mesh, which might be better for a report. Okay, so the next step would just simply be to open a report. And if you have a report, you can just view that report. And if you notice that the callout is actually updated already in the report. So if I wanted to adjust it, you can double click on the report, access that callout as a little alternative view, adjust it however you want. You can move it around, set it just as you need for your reporting purposes, close it, and it will update so that you have exactly what you want in your report. I kind of messed that up. We can move the callouts around as well, which I forgot to do. And close it again. So it makes it really easy to access this. And I realize I have not extracted my features yet. So to extract the features, all you need to do is right click and say refresh filter cloud. Now, the other thing that we did in this version was under features, there's an option to just use the generic filter button. And this will allow you to, again, select any or all of the features and use the saved settings from those individual features. So you're not overriding them, you're just simply using those features and trying to select the data, and it'll go through the list, run through the list one at a time, and evaluate each one. And as soon as the list is complete, you can again reopen your report, and you'll see that your callout is there, and all of your information is already filled out. So this really makes it very easy to do just about any kind of analysis you want with a template using cloud data. Okay, moving on. So what we've got here is a next section is looking at some of the just general reporting and usability improvements. Okay, so what we have here is a set of improvements for vectors specifically. What we've done is improve the computation speed of vectors. That was something that really actually ties to the name controls as well. Surprisingly, doing the name comparisons and validation of the names of the vectors were slowing things down. And we've come up with a more advanced method for processing the vectors and generating them quickly without having to do too many comparisons, which has really sped things up within SA. We also added the ability to control the naming for vector groups. This is a kind of a nice addition. It allows you to control the prefix that's saved with the vector group, so you can change that as you wish. That's something that's saved within the user options. Couple of other things for feature inspection specifically. If you're looking in the tree and you want to know whether or not a feature was measured effectively or if the extraction happened correctly, we now add a little symbol, a warning symbol, to help you clearly identify that there's an issue with a particular feature, and you can then inspect to see what happened there. We also have direct access to the naming control for features. So if you right click on a feature and go to its name, you can just simply edit it directly at the top. And that's something that's been standardized across all geometry types and other relationships as well. We also worked on GD&T user options. We've been improving some of the table layouts, trying to make it a little bit easier to read and access. But what really made a difference in this version is we added a special option to turn on and off the display of the distance out of tolerance. So the measured deviation is a value that's reported by the standard. The distance out of tolerance was really a debugging or error message that we were displaying to help people understand why it failed. And then we've had a couple of customers request that we just turn that off or have an option to turn it off so that you can have simpler, easier to read reports. We now have that option within the user options, so you can turn that on and off. We also spent some time working on debugging tools. So we have a couple of tools in there to allow you to generate points or solve geometry based upon whether or not a feature works as you intend. So what we're trying to do is help not only just do inspection effectively, but understand when a feature fails, what it is about the feature that went wrong, and then try and understand what needs to be done to correct that process. So that's a pretty significant advantage. We've been working to improve those things, and just wanted to share that with you. Okay, a couple more things on just instruments in general. We did add a new instrument, so let's run through the RTC360. We added update to RDS 6.6, which includes in color and intensity, and just generally did some improvements across the board for instrument support. So specifically regarding Leica Geosystems instruments, what we did in this version was add support for the RTC360, which is a unique interface that allows you to connect wirelessly and generate a scan. It's a great way to access the data, and because it's such a small, compact, effective device, it really just makes it an easy way to connect and gather data from the instrument. The other thing we did was add a new instrument model to support the TS20, also refined to make sure that it was working correctly. It's a really nice, very exciting new total station that's available in the market, and you can now directly use it within SA as well. But the other big major improvement that came along was the RDS 6.6. And as you can see in these pictures, if you're trying to detect rivets, for example, on a part, one way to detect them is just simply graphically looking at the color. And we can now save intensity, which is really just a color value with each point. And you can take advantage of using that data within SA to be able to access that information. So what I would like to do now is just share a quick video of that process with you. This is a panel that has some rivets. And one of the things that we're interested in is exploring ideas for how to use intensity and use it to accomplish specific tasks, such as detecting rivets. And when you have the intensity values, you really don't have any additional information. All you have is an extra integer that's saved with the data. So we have to access it in some way and be able to filter using that. And if you have ever played around with it, we have an option called RGB filtering. and believe it or not, RGB also applies to intensity. So we have a filter for intensity. You can look at the data and you can apply a filter that should split out the white and the dark. And you can play around with this filter and try and narrow it down to be a particular zone, which can be a little bit challenging, but you can play around with finding the settings that fit for you. And then you can just reset the data. It's a way of displaying based upon what's available in the data. You can work on algorithms to find the solution for this. And so what I wanted to quickly review for you is the idea that this doesn't have to be a hunt and peck. It can be much more strategic if you use a script. So if you open up scripts and just simply type cloud and collapse, you can see there's several sections with has cloud commands. And in here is a set for cloud filters. The cloud filters include getting the current RGB value, and we can now do that directly using a callout as well. So if I wanted to add a callout here, I can click on this and get the RGB value for that, and up here as well. So you can see the RGB values, and RGB is red, green, and blue. So with intensity, they're the same, but you're allowed to get that, and you can look at the RGB of the entire cloud, the RGB of the closest point near it, and you can subdivide the cloud using these things. So it actually offers a number of tools if you want to play around with it. One of the things that we did do was already develop a script designed for this process. So I can run this script and pick a target size of the rivet, and then just click on a rivet, and it should try and search and do a couple of things. What it does is it builds the zone around where I clicked. It then separates the cloud. So I have two separate clouds. One is the interior data, one is the exterior data. And what it does is allow you to easily associate that data to a circle and a plane. So you can do analysis of where those features are in space. So this is the kind of thing that is fairly easy to do with a script. You can just simply go and hit go and voila, extract another feature. Missed. Try that one again. There we go. So it's really a matter of just using the tools to your best advantage. And you can work with us to try and talk to one of the application engineers to see how you might use these cloud filtering tools to fit the needs that you have in your industry. Okay, I'd like to now return to the corridor and just expand the same concept. So again, we have intensity values. I can right-click on this and go to the RGB filtering and look at the intensity distribution and try and filter the cloud based on that intensity values. That's not particularly useful in this case. What I would rather do is actually take advantage of the RGB color that we can add to clouds. So if I go to the reporting tab and again perform my query to generate the colors using Cloud to CAD, generating a colorized cloud, I can select the cloud and the mesh and generate a colorized cloud. And then this, again, you can right click on it and play with the colors. You can play around with, say, let's do a go, no go as an example. This is a good example. Say I want to isolate the zones that actually fail tolerance, and you can just say, okay, that's the RGB values, but I can right click and go to RGB filtering now and try to look at the value for the actual red values and isolate just those values specifically. So I can go out to this extreme here and apply the filter. And you'll see what I've done is isolate just the red that was there from the intensity. This is the data that is actually failed. It allows you to have much more flexibility in filtering the cloud data and accessing just the regions of interest. So there are, again, very interesting ways of playing around with the RGB values, resetting the color, and then trying to filter using red, green, and blue to isolate the data and the regions of interest. And that's pretty much a wrap. Just wanted to share some basic information with you about the new version. There's a lot of nice things in here, a lot of upgrades, and a lot of potential that SA offers and brings to the market. So really just a quick review. We added a lot for robotic automation, robotic integration, understanding how to use robots and do automation through SA using its SDK. That's a real advantage that we've had for quite some time, but it's not something that a lot of people use or are aware of. And that may be something that this will really be helpful to you and your industry. These precision instruments is really perfectly tailored for that. So the 800, for example, is really set up to allow you to do robotic inspection. And the more that we can take advantage of that, the more you can automate systems, the more money you actually save in time and cost and personnel. Additionally, we added some really nice improvements just across the board for basic measurement needs and cloud processing in particular. So we now can generate some really colorful reports, and just wanted to share all that with you today. I hope you enjoyed the What's New, and with that, I will sign off.